Let's first define the radian. So we know how to measure angles in degrees, hopefully. So there are 360 degrees in a circle, we know that. But a radian is defined, and we're going to need a radius on our circle for this. A radian is defined as the angle subtended by a length that is equal to the radius on the circumference. So what that means is this length here should be equal to our radius. And the angle that is marked out by this length, we say is 1 radian. So that's our definition. How does that correspond to degrees? Well, if there are 360 degrees in a circle, how many radians are there in our 360 degrees? Well, we can work out the circumference of the circle. We know how to do that. That is 2 pi r. And let's see how many radii fit into my circumference. So I'm doing my circumference divided by my radius, and that should give me 2 pi. So there are 2 pi radians in my circle. So 360 degrees is equal to 2 pi radians. Hopefully that makes sense. Let's get rid of that there. And let's have a look at some of our other common angles. So 180 degrees. What's that going to be in radians? Half of 2 pi. So it's pi radians. And we can do this for our other common angles as well. So you can see that all that I've done is I've divided my 2 pi radians by a number, which is the same number that I'm dividing my 360 degrees by to work out my common angles in radians. But what about if they're not a factor of 360 degrees? What about if there's some other angle? How do we convert between degrees and radians then? Let's have a look at that. So say I had 54 degrees. How do I convert that into radians? Well, let's think about it. We can think about this in terms of ratios. 360 degrees is equivalent to 2 pi radians. That's what we started off with. So let's use fractions for this. We've got 54 out of 360 degrees. So that is a fraction of a full circle. If we multiply 2 pi by this fraction, we should get a fraction of 2 pi radians. And that will be equal to our angle, 3 over 10 pi radians. So that's actually quite a nice answer. That's giving it to us as a fraction of pi. But we can also write this here as just a number, so 0.94 radians. And those are equivalent to the same thing. So you've got to remember that radians can be written as a multiple of pi, which is how they're commonly seen, especially our standard angles here. We've also got to remember that radians can be measured as a decimal number as well. Radians are also very important when we later differentiate and integrate with trigonometric identities. So when we differentiate and integrate things like sine, cos, and tan, the angle that we're measuring in there always needs to be in radians. So we're going to meet radians later on when we start doing some differentiation and integration of trigonometric identities.